Hello, my mathematicians. This is Miss Foster with Math in Focus, 4th grade, Chapter 11, Lesson 1, using properties of squares and rectangles to find angle and side measurements. In Chapter 10, one of the challenges was to grab onto and deeply understand a whole bunch of new vocabulary. Horizontal, vertical, perpendicular, parallel, right angles, oi, oi, oi. This chapter is going to continue to challenge you in this way because it's going to use this vocabulary a lot. If you get confused, if you can't remember the meaning of the words, slow yourself down. Really pay attention while I'm teaching here. How many times do you hear this? Now, another new vocabulary word that I don't remember us doing so far this year is the word properties. And if I'm thinking about properties, I'm kind of thinking about what is someone's traits. So I have a puppy sleeping on my lap here. You might remember my new puppy, Luna. And Luna has several different properties. First of all, she is warm, and my wrist is cold. Secondly, if you notice here, she is infinitely cuddly and snuggly. Also, she is a poodle, and she is a she-poodle, not a he-poodle. She also right now is very young. When I am recording this video, she's only 4 months old. Oh my goodness. Also, she has the property, being so young, of needing to have lots of naps. And that is why, while I am talking to you, she will be napping quietly on my lap. So those are the properties of Luna. There are many more. But understanding the traits of Luna will help you understand her as a dog. Understanding the traits or properties of geometrical figures helps you understand them better and communicate about them better. So let's come and have some fun with that, shall we? I'm going to get a pen that I can easily use. Here is a square. Now, what are the properties of this square? Let's bring our very poorly spelled vocabulary here. No, Miss Foster, that needs to be an L. Thank you. So with the square, I could say that it has 4 sides. And there's sides. I could say it has 4 angles. And that all of those angles are right angles, which means that the sides that are adjacent or next to each other are perpendicular, but opposite sides are parallel. So did you hear me using all this vocabulary to describe the square? Now, we need to get into right angle a little bit more. Remember how I told you that a right angle is equal to 90 degrees? And maybe you remember how we measured that with a protractor. Well, that means that this whole angle right here is going to be 90 degrees. We know that this part of it is 45 degrees. So how can we figure out what little angle A is? Well, if I know that all of this from here to here is 90, and this much is 45, I think I could do 90 minus 45 and get my answer. I think I will do that right now. 0 minus 5, can't do that in positive numbers. Look at this regrouping. Aren't you glad you know how to do this here? There's my regrouping. 10 minus 5 is 5. 8 minus 4 is 4. And do you see this little circle right here? I'm going to draw it in red. This is secret math code. It's the special symbol for degrees. We measure the distance or the relationship between this line and the angle they create by degrees. I think you can agree with me that this angle right here is smaller in degree than this one. So I could say, just using some math, some addition and subtraction there, that the angle A is 45 degrees. Okay, well, what about this rectangle over here? Let's think about its properties. It has 4 sides, and it has 4 angles. And all 4 of its angles are right angles, because a rect in rectangle means right angle. So we've got those, and that means we know that every one of these angles is 90 degrees. That means that these vertical sides are perpendicular to the horizontal sides, and the vertical sides are parallel to each other. 2 pairs of parallel sides. Now, we have another puzzle here. If this part of the angle is 65 degrees, how much is little angle B? Well, once again, I know that the whole thing there, a right angle, is 90 degrees. So I could do 90 minus 65. And look, we're going to be regrouping again, aren't we? Because 0 minus 5 just doesn't work in positive numbers. Okay, that will leave me with 8 tens if I take one of those tens and break it up into single ones. 10 minus 5 is 5. 8 minus 6 is 2. This right here is a 25-degree angle. So we can use what we know to find out new mysteries. Now, these figures may not be drawn to scale. It says find the unknown measures of the angles in the square and rectangle. I am choosing to skip those because I think I already did a pretty good job. But if I didn't, please come see me in office hours or send me an email. Whoa! Now, these are shapes that we call composite shapes. They are not squares or rectangles. Yee! And when I first see these, I'm always thinking, oh no, I can't handle it. But would you notice something? Composite shapes can be broken up into rectangles. Ooh. So if I have this being a rectangle and this down here being a rectangle, can I figure out how long line segment FE is? Well, I know that AF is perpendicular to FE because I see this right angle sign there. It has to be 90 degrees. If AF is perpendicular to FE here, and FE is perpendicular because of that right angle there, I'll move this line so that you can see it better. If this ED is perpendicular to FE, then does that mean that ED and AF are parallel? Yes. Yes, it does. Huh. What about line segment AB? It is perpendicular to line segment BC. But do you notice how DC is also perpendicular to line segment BC? With these right angles here, does that mean that AB is parallel with DC? Why, yes, it does. And if I were to extend those out sort of like this, whoopsie, let me get in a triangle here. I could say that this space from about here to here would be, whoops, excuse me, didn't mean to do that, would be equal, please stop doing that, Miss Foster, you need to choose a different tool. There you go. Would be equal to this. So if I took 18 away from 30, would I find this distance right here? Yes, you would. So let's see, 18 plus what equals 30? Well, 18 plus 2 equals 20, and 20 plus 2 is 30. So I'm going to say that by using these relationships, I can tell that this space right here, FE, is 12 centimeters long. Here we have an even more complicated composite figure. It is made up of 3 different rectangles. All these right angles tell us that if PW is perpendicular to WV, then it's parallel to UV, isn't it? Now I know the distance from V to U is 15 inches. I know this much of it right here, and all these right angles are telling me that from here, this dotted line down here will be 4 inches, and this will be 5 inches. So the question is, what is this part right here? Well, if I put these 2 lengths together, and I took them away from this, I would have this remaining. So, PQ is 4 and TU is 5. 4 plus 5 is 9 inches. And if I took 9 away from 15 inches, I would be left with 6. And that is how I can find out that line segment RS is equal to 6 inches. Do you see how they're really pushing you here? Guys, this is not easy. If you are feeling a little like, whoa, it's okay. I was too the first time I did this. I can do it this fast because I've been teaching it for years. Now here they're just telling you we're not going to draw in those right angles. All line segments in these figures meet at right angles. Find the length of the unknown side in each figure. Okay, so let's take a moment and do some highlighting. Our vertical lines, I am so sorry, that was a very bad highlighter job, Miss Foster. Our vertical lines here are all parallel to each other. And our horizontal lines here are all also parallel to each other. I can break this figure up into 3 different rectangles. And that means I can use this relationship. This is 15 feet right over here. I need a pen. So if all this right here is 15, then all of it would be 3 plus our unknown, our we don't know, our DE, plus FG would all also equal 15. So if I add if I add BC, which is 3, and line segment FG, which is 8, 3 plus 8 is 11. And 15 minus 11, I believe, is 4. Are you getting that too? I believe that line segment DE is 4 feet long. What about this friend over here? Well, let's go back with our highlighters and think about parallel, horizontal, perpendicular lines. Go away there. I don't know why that's coming up. Okay. Our vertical lines are all parallel to each other and perpendicular to all of our horizontal lines, which are right here. Okay. And that means that if I put together, oh my goodness, we have something even more exciting down here. Do you see these little hashtags here? They mean that this line is equal to that line. And that tells me also that TS is equal to SR, which means, my friends, that if those two sides are equal and all these are right angles, have we found a square? A square is a quadrilateral, quadrangle. All of its sides, or all of its angles are 90 degrees, and all of its sides are equal. My goodness, by using the properties I understand about squares, I can know that this pink square has a side measurement of 4 yards. So that would be 4 here and 4 going this way, and 4 here and 4 going this way. And these little hash marks right here that are getting very dark now that I'm tracing over them again, these are just little marks that mathematicians use to say this is equal to that. And I'm going to tell you right now, nobody taught me that till 7th grade. So y'all are way more advanced than me. Oh, I can't wait to see the mathematicians that you will be. I know this whole distance is 27. I know WV is 4 and SR is 4. So what if I put these two together and took it away from 27? Would that help me to figure out my unknown length? Let's check. I think so. Well, 4 plus 4 is 8. 27 minus 8, I think, is going to be 19, because 7 is only 1 away from 8, but I have to stay in positive numbers. Oh wait, is it going to be 11? Let's see. I really wish I had that skinnier pen. 17 minus 8 is 9. Yes, it is. Oh, I was right about the 19. Look at that. And so that's how we would find those answers. Now you have some lovely puzzles to puzzle through on pages 83 and 89. We're not using fraction bars, clearly. I need to redo this, and I've been copying things and not editing them. Please forgive me. Do rewatch this video if you get stuck. Do talk to an adult. Your adults can actually help you with this. And pay attention to how much addition and subtraction and geometry you are doing. Really think of the traits of these squares and rectangles, just like we considered the traits and properties of this fuzzy little puppy of mine. Hey guys, thanks for interrupting Luna's nap time and playing math with me. I had so much fun playing math with you. Enjoy your composite figures. Bye-bye for now.